Here's my predicting reactions quiz tutorial. For the one that starts with potassium, I would take notes on concepts, not actual examples, but please take many notes to use during the quiz. Potassium is in a column that's labeled as a metal. So metals on their own are just the metal, it's just K. The charge is 0, by the way. I don't know if you want to put that, you don't have to. And then oxygen has the little star in the box on the periodic table that I gave you. And that means that when it's on its own with its own kind, we just say oxygen, then it is in pairs. It's diatomic, it's in pairs when it's on its own with its own kind. And its charge is 0, by the way, then too. I have kids putting -2. That's when it's with something else in a plus minus type pair, which this is not, at least not yet. So what could we do? Well, we have two things that are apart. Basically, we could put them together and that's all that you could do. Plus it says synthesis, which means creating, putting together. So let's put them together. So that makes K with O. Well, that's a +1 on your periodic table. That's a -2 on your periodic table, but the charges must add to 0. So there must be a 2 there. Then we can balance it left and right. If there are 2 oxygens going in, there must be 2 coming out. Do not put a 2 there. That will mess up the plus-minus pair. The charges will not add to 0 if you put a 2 there. We put a 2 in front because you can have 2 of the whole thing. And now there are 2 oxygens going in and then 2 coming out, and that works and that matches. However, we just realized that there are 2 sets of 2 potassiums coming out. That is 4, so there must have been 4 going in. Decomposition means it's going to fall apart, and we're going to cook it, basically. So let's write down the reactants. Copper, and it says it's a +2 there. With chlorate, look at your ion chart. It's ClO3, that's -1. The charges must add to 0, so there must be 2 of that. And then you look at your decomposition rules, and it says it makes oxygen gas and chloride compounds, which means stick chlorine on the other stuff. Well, that would be the copper. So we'll take copper, which we were told was a +2 this time, and stick it with chlorine, which likes to be a -1 when it's stuck to other things, other plus things anyway. Look at the top of that column on your periodic table off to the right, but the charges must add to 0, so there must be 2 there. 1 copper goes in, 1 copper comes out. That's pretty good, but how many chlorines go in? 2 and then 2. Oh, so that matches. All right, but how many oxygens go in? 2 sets of 3 is 6. So we better have 6 coming out. And we do that by having 3 sets of 2 come out, because 3 sets of 2 is also 6. Single replacement means we're going to have one of the pluses replace another one. And at first it won't look like it maybe, but silver is Ag because of Latin, and it's charged 0 if you care. You don't have to put a 0. But metals by themselves are just metal. It just says silver. The plus separates it. It is on its own, so it's just by itself. And then plus. Zinc on the ion chart is always a +2, you're told. And carbonate on the back on the ion chart is CO3 -2. So the charges have to add to 0, but they already do. So let's leave that. What could happen? Well, one of the metals could turn positive and grab something else, but you're not going to have a metal turn positive and grab another positive. It'll grab a negative. So what'll happen is this will stick to that. On your ion chart, we are told that silver likes to be +1, but it's going to stick to this negative, which is -2. The charges must add to 0, so this must be a 2 here. The zinc comes popping off and is off on its own, solid. Now, maybe extremely tiny bits, but it is a solid on its own. And so it's just Zn, and it's charged 0 if you care to notice or put that. You don't have to. Then we can balance it left and right. 1 zinc, 1 zinc, 1 carbonate group, 1 carbonate group, but 2 silvers come out, so there must have been 2 that go in. Double replacement, we're going to take the pairs and switch them, but it's easier to draw this probably once we get the reactants written out. Magnesium on your periodic table likes to be a +2. Carbonate, we just said, is a -2. The charges have to add to 0, but they already do. Plus nickel, we're told this time is a +2. Nitrate, look at the ion chart, is NO3 -1, but the charges have to add to 0, +2. So there must have been 2 of those. Remember, these charges are not really in our answer. They're just notes to ourselves. So you don't have to put the minus in or out of the parentheses. It's technically not even there. But don't wear out your eraser. Erasing is not worth it. What could happen? This plus could get a different minus. It could not stick to a plus, but it could stick to a different minus. That would be different, and that could happen. And this plus could stick to a different minus. So we could get those new pairs created, which would be Mg +2 with NO3 -1, but the charges must add to 0, so there must be 2 of those. And then we could get the nickel, which we were told was a +2, with a different negative thing, which is CO3 -2. The charges must add to 0, but they already do. So leave that. But something is out of balance, isn't it? Actually, maybe not. 2 NO3 groups go in, 2 come out. 1 nickel, 1 nickel, 1 magnesium, 1 magnesium, 1 carbonate, 1 carbonate. There we go. It's all 1, 1, 1, 1. That's fine. So the next one, magnesium likes to be a +2. Oxide means it's just oxygens. +2. Oxygen likes to be a -2. The charges must add to 0, but they already do. Plus sodium likes to be a +1. Chlorate, remember that one, is ClO3 -1. The charges add to 0, but they already do. And we could trade the pairs. This could go with that, and this could go with that. So we would have Mg +2 with ClO3 -1, but the charges must add to 0, so there must be a 2 there. And then the sodium is a +1. And the oxygen is a -2, but the charges must add to 0, so there must be a 2 there. Notice we have 2 chlorates coming out and 2 sodiums coming out. So a 2 here fixes both of those problems. And then we have 2 sodiums going in and 2 chlorates going in. So everything matches left and right across the arrow. We have H3PO4, and you're told that's an acid, and then potassium hydroxide. Potassium on your periodic table is a +1. Hydroxide on your ion charge is a -1. The charges have to add to 0, but they already do. This is a special case of double replacement. The H's are positive and they could stick to a new negative. The K is a positive and they could stick to a new negative. This on your ion chart is a -3, PO4. You can go look. Or you could figure out that there are 3 H pluses stuck to this. So that must be a -3 if this is a total of +3. And acid-base pairs, like we're working with here, make water and a salt, a plus-minus pair of the other stuff, which is K plus and PO4, which is -3. The charges have to add to 0, so there must be a 3 here. And then we can balance it left and right. 3 Ks come out, so there must have been 3 that go in. One set of PO4, one set of PO4. How many H's are on the left side now? 3 and another 3, so that is 6. 6 go in, so 6 had better come out. And 3 sets of 2 would be 6 coming out. Also, that's then 3 O's going in that aren't part of this, and 3 O's coming out. And so that all balances out.